Veronica Peroni here. I'm the CISO for North America at Detax Germany. Welcome to the masterclass on the topic 3D printed full dentures with Jimmy Stegall. Thanks for joining us today. I'm super excited to have Jimmy with us today. Jimmy is a veteran in the dental industry with more than 4 decades of experience. He's a CDT clinical educator, KOL for multiple dental organizations, and recognized 2024 NADL Educator of the Year. After leading a major dental lab in the Southeast for more than 35 years, Jimmy runs now his own firm, Here to Serve Dental, providing his experience to advance cutting-edge digital techniques in dental practices and labs across North America. Jimmy, it's really great to have you with us today. Before I hand over to you, to our listeners around the world, just an information that this webinar, this masterclass is being recorded. If you want to learn more about Detax and our products, feel free to reach out via LinkedIn or get in touch by email with me. If you have technical questions, we will collect and address them in a technical deep dive after the webinar. But we're here today to hear Jimmy's first-hand experience and his feedback on our latest innovation, the DX denture impact in combination with DX crown, which we have officially launched and introduced at the Lab Day in Chicago. And Jimmy, we are really excited to learn from you. The stage is yours.
Thank you, Veronica. Good to see you again. And let me get this presentation awoke. And here we go. Okay. Oh, here we go. All right. So, this has been really cool. I think most people that know me know that, after I left the lab after 37 years, I went to work for a major manufacturer who was really engaged in the development of digital dentures. So I've had some time to, develop workflows, look at materials within that organization. And starting my own firm last year gave me the opportunity to start looking at other things that, we all know that people develop and, the markets expand, which I think is good for us as technicians, because I've always said this, it's all about options. There's never one answer for anything. And, when Detax reached out and said, hey, we'd like you to, print some of our upcoming resin and see what you think, I said, sure, because, several people had already done that. But I got to tell you that when I printed this material, my eyebrows went up. I said, this is actually very good. And, I had heard of Detax through my connection with my last role. And so I knew of their reputation. I knew their capabilities and that they had been making resins for a long time. And so, that gave me confidence to say, yeah, let's give this a shot. And so, I printed the denture base, I printed the tooth material, and I was really impressed with what I saw. And so I was able to, do it according to their instructions. They spent a lot of time, like all manufacturers do, when they're bringing things to the market, the validation process to make sure that, we understand, the nesting and the orientation and the processing and curing. And so I followed their protocols, but also implemented some other protocols that I had learned along the way with other materials that I had used, and just to see the response and reaction of the material and how it impacted the workflow. But there are validated workflows. And if we're looking at this material, you have to look at that very close. But I'm going to share with you my experience about, what I saw and what I heard. Now, when I first looked at the free print impact, I started looking at where they had come, and they had a free print denture base before this one, and it was not called Impact because it was what we typically term a Generation 1 denture base resin, which is not in American terms high impact strength. So anti-fracture toughness has to be above a certain number to be called high impact. And their first version was not, but most everybody that made a denture based material in the beginning was not as well. So Generation 2, as far as Americans are concerned, we figure as a definitely a high impact anti-fracture, permanent type denture. So I got the information and I noticed it was, I got a list of printers and I saw a Sigma Max, but I didn't see Ultra, but I reached out to them and yes, they had been validating Ultra. So they gave me the INI settings for the Ultra. So I printed the base material in both the Ultra and the UV Max. I have one Ultra and two UV Max printers. And so we'll go through my processes and my workflow and my experience of the test. So when we're printing a part, and some engineers, chemical engineers, printing engineers have figured out, what is the best method of orientation, what is the best angle, and what is the best method of supporting, in addition to all the other printer settings for time, light, temperature, all that. And this was the IFU that I received from Detax. And as you can see, the dentures are oriented in the schematic with the anterior facing the platform, which was familiar with me because in the beginning, with other materials, that was the same thing. But along my journey, what I found was orienting denture bases heel to platform eliminated one significant problem with the finishing aspect, and that is having the ability to not have a support on an anatomically contoured area allowed me to maintain the aesthetics of that area. If we put a support on the buccal flange of a denture, when we're in the finishing phases, there's going to be these leftover printer nibs in that area that we'll have to smooth down, which means we're going to be softening or de-emphasizing festooning, root eminence, cervical roll. And so I always favored the other direction for that reason. But, I had the protocol, I understood what I needed to do. So you'll see in my images that there are some dentures oriented anterior down and some dentures oriented heels down because I wanted to compare. So this was a very first batch that I printed in the Ultra, and you can see I printed one each of upper and lower with the anterior and to the platform and the heels to the platform. They all printed well. There was no misprint. Accuracy looked good, and it wasn't until later that I did the comparative file scans to see and go ahead and give you that answer now. Again, this is Jimmy, but the heel to platform dentures matched the original design file as close as the anterior to platform. But we'll wait on Detax to validate that. But as far as Jimmy's concerned, I thought it worked well both ways. So that was the first printing. This was my next pleasant surprise. In the Ultra, those bases printed in 1 hour and 19 minutes, which was at the time the fastest that I had been able to accomplish a denture-based print job of any resin out there that was a Generation 2 high-impact material. So, and in the UV, 1.5 hours, which was still better than any print job I had experienced of a denture-based Generation 2. So the speed was exceptional in my opinion, and was very excited about that because it's all about productivity and the ability to keep up with demand and, with fewer technicians and all that that's happening globally. I have not printed any of the tooth resin in the Ultra. I've pretty much kept that on the Max because it's worked so well. And as you can see, 38 minutes for a print job. And I had, 4 arches in the first run just to see. And so print speed, I think, gets an A+ in my book because it's really good. So printing, orientation, angulation, supporting, and then speed, you know, all went really well. So, looking at the IFUs that Detax sent me, it says, okay, here's how you post process. And I was excited that, immersion in 99% IPA, as I had been using for almost everything out there, was good for denture bases. But printing or washing teeth, not all tooth resins can be immersed in isopropyl alcohol. Some of the resins that have ceramic fillers that I had been using from other brands to print denture teeth took a lot more handwork for washing because IPA would typically expose a ceramic, make the tooth segments look a little chalky. So you had to just do a wiping or a light brushing or a misting of IPA. And it was a lot of handwork. So when I saw that I could actually drop the tooth segments into a jar of isopropyl alcohol, that was exciting because, again, efficiency, speed. And so I'm going to go through, the validated, what they gave me using isopropyl alcohol, but I'm also going to share with you another solvent that I use routinely now. It's called a NovaPrint Wash, and I like it because it's not flammable. It doesn't have an odor. It can be used multiple times. Even when it's dirty, it's very effective. A little more expensive than isopropyl alcohol over here, but it's very effective at cleaning some of the more viscous resins. But let's look at the validated workflow first. All right, so I'm just using a basic generic ultrasonic, no heat whatsoever. You want to avoid heat, I think, in any of the polymers as we're working through the processing steps until it's time to cure. And so no heat, and we're going to do 2 baths of 99% IPA, and both alcohol should be clean. Right. So fresh, clean IPA, first bath, 3 minutes in the ultrasonic, take it out. And I'll tell you, do a visual inspection after that first bath. And I'll tell you, most of the resin residue is off and clean of the surface. You might see a little bit of residue in the edge of a pocket or on the intaglio. And what I'll do is I'll just take a brush and dip it in some clean alcohol and scrub those areas lightly. But then I'll drop the parts in a new jar of fresh IPA for the second bath. And, I have not seen one come out of that second bath yet that wasn't completely clean. I didn't see any shiny material left, which would indicate residue, or any white specks, which would indicate residue. And the key is, after that second bath, do a really, really good air syringe dry. And you want to let these parts sit for at least 20 minutes or so because we want all the residual alcohol to evaporate out of the pores or the porosity. This is 3D printed, not cured. So there are some open molecules there, and we've got, alcohol down in there. We want to make sure all that evaporates out. But it's 2 baths of clean alcohol. And this is normal with all the other systems that we've done so far, right? You always want to use clean alcohol. We've learned pretty quickly that if you use alcohol that's been used prior, and it might have a cloudy appearance, or it might have, specks of white residue floating around in it, that can be very problematic to a part. If we put a denture in that kind of alcohol, we see some of that dirty alcohol soaking down into the pores and then showing up later as white streaks. And it may happen 2 or 3 days later. So it's been problematic. So we always ensure that we're using clean alcohol in every bath. And you can see how good they came out. So looks like the video is lagging a little bit, but, just give you a quick run through of how I get them off the platform. It's pretty much handwork. The support methods, I used a contact width of 0.5. Which, a little bit harder to get off, but it kind of really reduces the risk of misprints. And if the video will speed up, you'll see another thing that I do that really helps the stability of my prints. And you see the Max in the foreground, but the Ultra's in the background. And this is the Ultra platform. So you can see I got 4 on there really easy. The best day I ever had with how many dentures I could get on an Ultra platform was 10 or 11, I think. So we're going to just snap these off with our hands, and then we'll take the printer supports off the denture by hand afterwards. Now, if you noticed, all the dentures had horizontal bars in the palatal areas, and we do that to prevent distortion during printing. And we leave those on, while we're cleaning and getting everything post processed. Looks like my video is not going to speed up, so I don't want to sit here and well, here you can see I'm removing what is a solid plate. And this is something I do on any print job where there's more than one or two things on it. I will print that 3/10 of a millimeter plate first as the beginning of the print. And that just gives my parts a lot more stability and has really reduced the risk of misprints for me. And it makes the cleanup a lot easier as well. So what's going to happen next is I'm going to take the supports off the dentures. I'm going to start dropping these dentures in some clean IPA and then dropping them into the ultrasonic for the 3-minute bath. And I keep hoping this will speed up, but it looks like it's not going to cooperate. So I'm not going to cause this pain on you anymore. So you saw the images before, how clean they were. So these are images using my alternate method. And with the InnovaPrint wash, I typically do a 1-minute bath instead of a 3-minute bath. And InnovaPrint wash, again, non-flammable. Store it any way you want, ship it any way you want. It's water soluble. So after the first bath, I will rinse it with water to examine to see residue. And I'll tell you, in most cases, with most resins that I've used, it's clean. I always catch myself saying, do I really need to put it in the second bath? I always do, just to be safe, but I have very seldom seen any residue after that first bath with an InnovaPrint wash. But I went ahead in this one and did a second bath in 1 minute as well with clean InnovaPrint wash. But I will use both those jars again for at least 3 or 4 times before I'll either filter them or dispose of it and start fresh. So I like an InnovaPrint wash, but you can see the dentures. Let's see if I can give you a comparative. Yeah, you don't really see a difference. They're both clean, right? And that's all that matters. We want to make sure we get all of that residue off of the surface. Now, with the tooth resin, the validated method is to take your air syringe and blow most of the excess off. And then we're going into fresh IPA, 1-minute bath, immersed. We're going to do that twice. And that's exactly what I did. And you can see I was very excited for this because with some of the resins on the market, if you do this even 1 minute immersed in IPA, they'll have a chalky, and it really takes a lot of effort to get it off. So you can't immerse some of the tooth resins out there. But this one, 1 minute, it came out pretty clean the first bath, but I did it a second time as instructed. And then you really like the denture base. We want to let that alcohol, that solvent, fully evaporate off the surface. So 20 or 30 minutes on the bench top before we start anything else. Now, I wanted to try the alternatives because these are some of the workflows I've done with other resins. And so I use the InnovaPrint wash, 1 minute, rinsed it with water. Then I did a 1-minute IPA bath. And because I use that for 2 other resins that it seems to work well, but then also did an InnovaPrint wash, 2 baths of PW. And all in all, at the end, every part was clean and done. So I don't think it matters which one you use, but we will certainly wait on validations. Why use an InnovaPrint wash instead of IPA? Well, it's just easier to store. We don't worry about the flammability effect. Shipping, you can ship it any way you want, and it is very effective on the thicker resins. So that's how I got everything clean. So once we have things clean, then obviously it's time to start assembly. Now, my first test, I looked through the workflow and I saw that we were going to be curing these dentures in my auto flash. And auto flash, I think we'll see it in a second, but I think it's 2,000 cycles and flip them over another 2,000 cycles. So, I did the math and I looked at that and I realized that's not a super high temp. And in the past, we had left these T-bars on the dentures during curing when we were curing at 80 degrees to 100 degrees Celsius because of that high temp. And we wanted to help maintain the stability. But in my eyes, I thought, well, this is the auto flash for only 2,000 cycles 2 times. It's not going to get hot enough to distort it. So I removed the T-bars before I cured them. Now, looking back and talking to the Detax folks, I think they would prefer I leave the T-bars on during curing, but we'll work through that and see what helps. And you'll get the image here as we go through it of why I think it's a benefit to cut the T-bars off now. So the tools I use, right? I use a micro wire cutter. Get them at any Lowe's or Home Depot or Amazon. And my favorite tools for smoothing supports are adjusted areas on polymers are these Wagner Aeroflex wheels. And I've tried rubber wheels and I've tried buff wheels, Scotch-Brite type wheels. And I have found these Wagner wheels, which are very unique. The best way to describe them to you is that they are a hybrid rubber wheel, Scotch-Brite wheel. So I can tell it has kind of the Scotch-Brite, content, but it's rubberized. And so they're durable. And these are the two that I keep, and they are my go-to for just about any polymer out there. So I use the black one, which is the fine, for the denture base, and I use the red one for the tooth segments. Now, I could probably get away with using the red one on both, but I started this way, and it's kind of the way that I've stuck with it. But what I'm going to do is I'm going to use the wire cutters to cut the T-bars off, and then I'm going to use these little wheels to smooth all the supports. And so it's pretty simple. The wire cutters make it great. It eliminated the issue I had of trying to use a separating disc for this and, gouging the pallet and area. So I try to get as close as I can with the wire cutters. And then I'm going to use that Aeroflex fine to smooth down those areas. And one of the things that I really enjoy about this printed polymer that these guys have done is the way it finishes. I mean, it's very much like finishing composite. So I don't get any peeling or rolling. And, it's a powdery finish. So it's easy. It's very simple to smooth down and easy to clean up the residue. And you want to do that, right? We want to make sure that we get everything smooth. If you have print lines or, mismarks you need to smooth up, this is a great way to do it. And so I love this method, and it doesn't take long at all, just a couple of minutes per part. And it's quick and it works. So the Aeroflex is a great tool for this. So I'll sit here and spend a few minutes, smoothing, adjusting. And I'm using the Superfine here, but you'll get the idea. So you see the printer supports. And a lot of this is figured by a Siga composer. And, I notice here in this picture that I see some supports up in the post-palatal area that I'll have to smooth down, which is probably not a great idea. We were always taught that the intaglio area is a no-go. Apologize for the laggy video. I think this is a new platform for me, so I haven't tested this through LinkedIn before to see how this works. We'll have to work with them to see if we can speed this up, but I will spend somewhere between 2 to 4 minutes. Now, the key to using these Wagner wheels is a very low speed. I'm somewhere around 8 to 9,000 RPMs and a very light touch. I think this is true for any of the printed polymers. These are all heat sensitive materials. And so I don't want to generate a lot of heat with my instruments. So very light touch, but I'm going to go around the edge on the heel to platform dentures because that's the only place the supports exist, or on the borders. Of course, on the anterior to platform dentures, I'll have to do this on the facial to smooth those areas down. But again, this still takes maybe 2 to 3 minutes. It's not a long process, and it's just very light passes. I check it with my fingertip to see if I can feel anything, and a couple of passes with just one wheel, and I've got it done. This is the super fine at a 3.5 millimeter thickness, probably better suited for tooth segments for the flexibility and embrasures, but it'll work for the denture base. But I think I'll use it up a lot faster. I think the black wheel will be more durable finishing the denture base. So I typically use the black wheel. Again, I'm going to skip through the video since it's dragging. So you can see that I'm using the black wheel in the images, and I'm just smoothing those nibs just a couple of minutes. And then I keep a little jar of isopropyl alcohol and a toothbrush, and I'll just dip the toothbrush in clean IPA, and I'll brush all this dust off. I don't go immerse it again. I could go drop it back in the IPA for 30 seconds, ultrasonic, just to get all the dust off. I could probably go over to the sink and rinse it off with the water, but it's just easy to keep a little jar of IPA on the bench and just do a quick scrub. It comes off pretty quick. And again, I'm going to air syringe that and dry it really, really well. And because I've added more IPA, I'm going to let that sit there for 15 or 20 minutes to, again, I want all that alcohol to be evaporated. But the goal is to eliminate all the spots, right? I want this denture to be smooth. This is my finishing step, because as you'll see, I'll move into the final steps. When I come out of the curing box, I want to be done with this denture. So I don't want to have to polish it or smooth it. So you can see me using the super fine Aeroflex, but also a Scotch-Brite wheel. Well, I'm using the Scotch-Brite wheel because in the printing orientation for the tooth segments, the IFUs from Detax was occlusal to platform, and that was a departure from how I'd always done teeth. I've always put the supports on the basal side of the tooth segments. All my dentures are designed with 2 posterior segments and 1 anterior segment. But because their IFU said on the occlusal, then I didn't want to get too aggressive with the rubber wheel on the occlusal surface, so I used a Scotch-Brite to try to smooth those down a little bit. But you get the idea. The goal is I'm taking the nibs off. But this would be my typical method, is using these Aeroflex Superfine 3.5, very flexible, and it's a very, very light touch. And I'm 8,000 RPMs, very light touch, and just taking the nibs down. My goal is to remove the nibs, but not take any more tooth. And so that's why I like using some sort of rubber instrument. You could do it with anything, right? I've trained technicians that said, "Can I use a carbide?" And yeah, if you're that good with a carbide, to me, a carbide is just a higher risk instrument that I just run a much higher possibility of taking too much away. So I like the Aeroflex wheel for that, and it doesn't take long at all. It's just a few seconds per segment, to get those reduced down. So once we have everything smooth and clean, then I have to check and make sure that the segments fit. And I'm just looking for a rock. So you'll see me seat them and just, check the cuspid to cuspid to see if I've got a rock, and I'll just confirm the fit. And we call this dry fitting. So we clean it, we remove the supports, and we just check to make sure we fit. And I'll say 99% of the time they fit. I mean, it's just software and technology, and the printers are great, the resins are great. So everything fits, and I'll be ready to go to bonding, after I do this final check of the segments. So again, you see that all my dentures are designed with 3 segments. That's topic for another discussion, but designing a single arch is more problematic in almost every step of the workflow and takes longer. So doing it in 3 segments makes everything go much quicker, and aesthetically, it's fine. So we've got everything ready now for assembly. So the IFUs, and you can see the big black bottle, that's, that was the sample bottle they sent me, and that's the base material. And, this is easy, right? We're going to bond the teeth with the same material the base is printed out of. And there's lots of good reasons for that, right? It's the same material, so it's going to stick to the base really well, because remember, the base is not fully cured. So I just get these little light cured syringes, and I load them up with whatever my bonding material here. You see also a little small brown bottle. That is the Dentsupply Fuse 2, their bonding material. and I wanted to use it because it is a method I use quite often. But it's the same concept. The supply material is the same as their base material with, I think, some other chemistry in it, but we're looking at the same concept. But I also use a pack dent product called the Rodin Glaze N2F, and it is not only a glaze but also a bonding material. So I'm going to show you the different ways, but we'll start with the validated way, right? So here I've got the Detax denture-based material loaded in a syringe, and I'm just injecting it into the pockets. This syringe just makes it easy for me. You could put it in a dapping dish and dip it up with a brush or a waxing instrument or something, but the syringe just makes it a little simpler for me. And I'm just going to put enough of the bonding resin in the pockets, and this is true across all platform and materials, that I want to, when I seat that segment, I would like to see a small bead of excess all the way around the teeth. That tells me that, there's no air pocket and I've got a good layer of bonding resin. The software has allocated the amount of space for the resin, so I'm not worried about that. Most of the tooth libraries that we use are designed so that there are areas on the basal side that are designed to actually bottom out, so we maintain our occlusion. So I'm not worried about that either unless I put supports in those areas. So I'm careful about that during the supporting phase. But this is a pretty simple process. It takes me about 5 to 7 minutes. So I'm squirting the resin into the pockets, seating the segment, and wiping the excess. And here is, wiping the excess is where I'm a little bit meticulous around the margins, because it's easy to make these dentures look kind of plain or unnatural. If you leave the excess resin in the gingival margin, it just doesn't look as natural. So when I seat this and I start wiping and cleaning this excess, I really take a minute or so to clean around the gingival margins. And I found some instruments that help, but anything, a brush, a pointed instrument, I try to avoid anything cotton. So you see the things that I use are felt or sponge. And it's just, the goal is let's maintain as natural a look as we can around the gingival border, because without that the teeth start to look a little fake. So I'll seat it, hold the teeth down with my finger, light pressure, but just hold them stable while I'm cleaning the excess. And again, I'll use a non-lit gauze wipe, a foam paddle instrument that I found from the copier industry, a pointed foam instrument to clean around that margin. But it takes me a total of 5 to 7 minutes to do all of this and have this denture ready for curing. And so this is just a few seconds, even with the laggy video. But we'll see if we can get the video to move forward a little bit and show you how I'm cleaning that up. Yeah, this video is lagging, so we'll move forward. All right, so free print resin in the pockets, just from a syringe I loaded, seat the segment, wipe the excess, and then I use a low UV light, a low volume UV light. I don't want a high bright curing light because I don't want to cure it until I get it into the nitrogen environment, but a low light just to tack it in place for a few seconds. So the other two methods I used was the loose tone digital fuse, to bond the segments in, and then the Rodin glaze. So what is this glaze? Well, the Discolor system has one. They call it Fuse 3 Total, and then the Rodin N2 Free Glaze. These are, I love these materials because these materials have pretty much eliminated me having to go to a pumice bench. So now you can begin to see the benefits of making sure that we smooth all the printer supports and any adjustments on the denture base before we get to this step. We've tacked the teeth in place with whatever system we're using, and then I will paint this glaze over the teeth and the gingiva. Now, the thing I like most about this is that we're painting this glaze on before we're putting the dentures in the curing oven. And so remember, they're printed, not cured. So there's still some open molecules, which means when we paint this glaze on, it actually goes subsurface, maybe 10, 15 microns. And then when we cure that, it actually bakes that glaze in. So this is unique to any denture glaze we've ever used before. Every other denture glaze in the market before this time has been a paint on after the curing, right? A surface glaze, a shellac, we call it. And that's fine and good, and it works. But they do have the nuance of, they're going to show some signs of wear, of cracking and peeling in a time period, depending on the patient's, care. This just doesn't happen that easy. It is actually almost like a ceramic glaze in that it's, grabbed into the surface depth of about 10 or 15 microns. So I love this aspect of the denture process because it totally eliminates having to stand at the pumice bench. So another aspect of this glaze, though, these polymers, again, because they're not fully cured yet, right? Even when we cure them, you really need to polish them well, or you use this glaze. If we don't glaze this material or polish it well, then it is more susceptible to stain and wear than traditional methyl methacrylate dentures. And I've seen it, right? And so we want to do this. And I like the glaze because it's just a better time savings and it does a good job, but you've got to apply it and you've got to apply it well. If you don't get it applied well, then you could easily see staining quicker than we'd like. So one of the negative nuances about the materials is that they evaporate pretty quickly. And so if I paint this glaze on a segment of the denture and then I move to the next segment, by the time I get to the end of the denture, what I painted on first could be evaporating out of the pores of this denture before I get to the curing oven. So what I like to do is that I like to set my sealer as I go. So I will paint it on and light cure it just with a low volume light for just a couple of seconds. It's setting that sealer so the evaporation process won't mess me up. So after I paint the glaze on, then I go into the auto flash. And again, it's 2 times 2000 flashes, just flipping the dentures over part way. And here you can see some of my finished cases over Veers, and you can see that I've made some notes to help me understand which printer and whether I oriented them up or down and which bonding resin. And all in all, I didn't see many variances. I'm pretty pleased with all the results. Just in laboratory hand testing, they felt to me against the burr and against me breaking them the way I can break them, every bit as strong. I'll give you some numbers in a second, but I don't see a problem with strength looking at the numbers that Detax gave me in my experience. So strength, I don't think is an issue. But one of the cool things about the results was we've had some issues with printed tooth resins, right? And there's been a number of, oh man, it doesn't look quite right. But I think these guys have done an awesome job of matching shade tabs. Think about it. We're printing teeth out of a monochromatic bottle of resin, but we need them to look like a VITA shade guide, which is not monochromatic, which is multi-layered, which is a different material. And so that's always a challenge. Anytime you're making a restoration out of a material that's a different material than your shade tabs, and the industry's figured out how to do it with multi-layered pucks and all that. But with a monochromatic resin, it's been a challenge. And I think with libraries, it becomes easier if we can have a denture tooth library. It's a little thinner on the incisal 1/3, then we get some translucency. But overall, the shade on most resins, because they are a translucent resin, is that they tend to have a value that's off. It will be B1, but the value, I'm not sure it's a B1. So I was really pleasantly surprised when I saw that the value on this Detax tooth resin was very close. Now, whether that's due to the short print time or the fast cure time, and as you can see, using various methods, I didn't get a ton of variance. The shade was pretty good. if not spot on, in all my different workflows. So I was very excited about the shade. So these are the numbers the engineers at Detax gave me. And if you compare those to some of the popular Gen 2 denture-based resins and printed tooth resins on the market, they're very, very similar, very applicable, better in a couple of numbers. Nothing that gives me any alarm here. So really like the low water absorption, the flexural modulus. So, and the wear strength numbers are also very good on the teeth. So I don't have a problem with the numbers. I think they're great. And, I think we're going to see good long-term results out of the Detax material. So that's my experience. I wanted to, leave time for questions. I did want to share with you my website. So this QR code will take you to my website. If you want to reach out with me, ask me follow-up questions, or as you develop your workflows, you have problems and you need some help, just reach out to me on my website. You can contact me through there, and let's connect back with the team and start answering any questions.
First of all, Jimmy, huge thank you very much for your valuable insights. It's been an absolute honor and pleasure to have you with us. We learned a lot from you today, and I'm already very excited to work with you on other projects in the near future. And thanks, of course, to everyone who joined us today. Sorry for some slight technical issues with the videos, but we will make sure to upload this presentation on the platform. So since it was our first experience with the live broadcasting, let's say via LinkedIn, sorry for that. We will make it better in the future. And maybe just some short information at the end. Our resins are available through authorized distributors in the United States, for example, through Bancor or Articon, and the new denture Impact, which Jimmy talked about, will be available in May of this year. So we are very excited about that. And please make sure to follow us on LinkedIn for updates, or check out our website, detax.com, for further information. And hopefully, I will see you everyone at the IDS in Cologne in a couple of weeks, where we can sit down and talk and have a coffee. Please stop by at the Detax booth in hall 10.2, and our team is excited to talk to you. So I think the question round, since we are not familiar how it works with this platform, Jimmy, we thought that we will collect the question if we don't see any here in the chat, and then address them after the seminar, after the webinar, and we'll put it on our LinkedIn, and we'll connect them. What do you think?
So you said you're recording it, and you recorded it even with the laggy video. So what I'm going to do is I'm going to put in the chat a link to this presentation.
Oh.
And so anybody that wants to go back and click through it, just click on this link and you can watch my presentation. I mean, I think that's fair, since things weren't working great, and you guys did it come through? Again,
I think I received it in the private chat. I'm not sure if we can in the backstage. Janos, can you? Okay, thanks. I think now it's visible for everyone. Yeah. Okay,
good.
That's cool.
Good. So you guys are welcome to that. Again, you have any questions, you can reach out. I'll tell you what I'm doing. So I still got some resin in the bottle. So I've got some more dentures to print, and I really like the state of the tooth. So I've used it on a couple of other cases. So thank you.
Thank you, Jimmy. Once again, we really appreciate having you with us. And thank you for the great presentation. We look forward to seeing you soon and doing some exciting projects together.
Absolutely. Yep. There's one I'm really excited about.
Thank you. Thank you for the listeners. And I would say that's it for today. once again. Thanks for participating, and see you later. See you soon.
Thanks,
Stay tuned.
Veronica. See you soon.
Thank you, Jimmy. Thank you.